Thank you very much, sir, for a detailed explanation about the patent publication process. So, dear students, if you observe that one, a small modification will give a rights on that patents. Okay, in the cinema also we seen in cinema most of the people already seen or bike they are taking the patent to get the rights on that one. One company purchased something. So like that, a small with the help of the some small modification, you are able to get the complete rights on that one. And once you get the rights on that one, you are able to encash that money. Okay. So it is a simple process. So once you get the patent publication, you have rights till 20 years. Okay. So most of your projects need to convert into patent. Okay, that is the our department motto. And SAR will help in all the aspects while while filing the patents. If you require some help from him. So on the other session, we will discuss about the research methodology. And by taking the simple problem, how to solve a problem, we will discuss in this session, very small. So generally, in the patent also, we see that one, a small modification, okay, exist for existing one, a small modification is required to get the rights on that one, okay. So like that, in case of the research also, what we have done, the name itself indicates research, replace search, okay, that means there is some existing work is there, but you need to revise that one and you need to identify a problem and you need to do to get the solution. So research is a project of finding the solution to a problem after thoroughly study and analysis of the situational facts. So in the project work, you are not doing the some extra additional thing. What you need to do, first of all, you need to have some idea about that one. Every technology is already used in the some other applications. Okay. But what you need to do, you need to study what are the existing methodologies on the particular work, and you need to identify some problem. Okay, for that problem, you need to try the solution, how to get a solution with the help of the existing methodology only. Okay, we are not creating something. Okay, in the nature, everything is available. That's why the name itself, it is indicating the research only. Okay, replace search. Okay, that means for existing work, where it is available and what it is doing. Okay, so how it is helpful for us to find the solution for our problem. Okay, so that thing only we are doing in the research. So for there is some criteria. There is a criteria for a good research. First one, we need to define the problem. Okay, for what purpose we are doing the research. And after identifying the problem, you need to observe what is the procedure to find the solution. Okay, that means in the mind, you need to have some idea about which process I am able to get the solution for our problem. And then while creating the process, you need to design, have the complete plan. Okay. So on what way we are able to find the solution for that, you need to have the complete plan on that one. And while implementing that plan, okay, you need to follow the ethical standard, because most of our research publications we seen in the present days, they already published somewhere, and some of the journals also there. Okay, by taking some money, even though it is published somewhere, they will publish with our name if we pay some money. So that's why while making the publication, first we need to have the same ethical standard. There is some little bit modification is there or not. So once there is some modification is there, then we are having the rights on that one. Okay. Otherwise, without doing anything, any small change, we can't publish some other work on behalf of our name. Okay. So that's why we need to follow some ethical standards. So, and we need to have some adequate analysis while taking the decision on that one. Finally, the whatever the findings you are done in your research, your project work, okay, you need to present unarguably. Okay, so that means the finally we need to make the conclusions. So this is the process of the research. In that, first of all, what we need to, this is the define research problem. Okay, for example, you are doing the project work. Project work means what you have done by taking the some problem. Okay, so for that problem, we are trying to find the solution for that. Okay, this is the final solution. So in this, okay, we need to follow the some procedure. First of all, we need to define the problem, and we need to review the concepts, and we need to review the existing research findings. Okay, on a particular problem, what you need to do, you need to review the concepts and theories, and you need to someone other than us, they are already done the some work on that area. Okay, on that area you need to identify the what are the previous research findings are there on the same. Okay, after identifying all these things, you need to formulate the what you need to do. Okay, that means here you are having the problem in your mind, and then you have done the literature survey here. After doing the literature survey, you need to formulate the some hypothesis to solve your problem. Okay, so that means at the in the first semester you have done these things. Okay, if really doing the your literature review in the first sem, now you are at the third stage. Okay, after that one, what you need to do, you need to, once you are having the some plan on that one, you need to implement the same thing step by step. Okay, so that means, so from this one, so what you are getting the conclusion, nothing but you need to have the something in your mind that research means, project work means you are doing the existing work only, but from the existing findings, you need to get the solution for your problem. Okay, you need to get the solution for your problem. Okay, that is only you are doing here. So these are the different definition of the problem, clear cut, the research objectives, all those things. So literature review, in the literature review, what we have done for the existing work, we are trying to find the what are the existing methodologies they are using to find the solution for their work, their problem, and you need to have the concept in your mind how to complete the your solution with the design process. So in the literature review, already in the first semester you have completed this thing. That's why I'm keeping that one. So in the today's session, what we have done, we are taking the some simple idea. Okay. So what are the steps to be followed to find the solution? Okay, you may do in the work on the power electronics area, control system area, electrical vehicles, or some power system, whatever may be the area of the work we are doing. Okay, so there is some procedure is there. So in that procedure, what you need to do, you need to take the first of all, you need to identify the problem, and from that problem, you need to have the some roadmap to find the solution for that one with the help of the existing methodologies in the other work. So from that one, you need to find the solution. Okay, so in the today's session, what we have done, we are taking the some overview of the one system I have considered. Okay, on that system, what is the necessity of the DC to DC converters? I am trying to find. After that one, what are the steps to be followed to find the solution? And these are the different steps we are following here. So this is the, if you are doing the some work in the power system area, generally we are having the some power system network. There is some generation, and there is some transmission, and there is some distribution system. Okay, if you people are doing work in the power system area, just identify that one here in the generation side, or in the transmission side, or in the distribution side, there is some problems are there. So you need to identify the what is the problem. Okay, and you need to identify the what is the roadmap. Okay, to find the solution for your problem. Okay, and here there is some other one. So here I am taking in the power system from the power system network, I am taking the renewable energy sources, and here I am using the some DC loads. Okay, here in the renewable energy from the we are getting the variable DC, and for driving the DC loads I need to get the fixed DC. So with the help of the DC to DC converter, I am trying to make the variable DC into the fixed DC to drive the our DC loads. Okay. The similar manner, here I am taking the one application. This is the where are various sources are there. One is the solar, windmill, and fuel cell systems. Okay. From this one, we are getting the some variable DC, and here I am trying to charge the electrical vehicle. For charging the electrical vehicle, I am requiring the fixed DC, but from the sources, I am getting the variable DC. Okay, now the use of the DC to DC converter is what? I need to change the variable DC into the fixed DC. Okay, so while changing the variable DC into the fixed DC, here I need to use the some controller. Okay, now that means we are having the some generating sources, and we are having the loads, and for our purpose we are inserting the some converter here. Okay, while using the converter, again what you need to do, you need to place the some controller. Okay, that controller where you need to place either at the source side or at the load side. Okay, that means your work is going elaborately. Okay, so that means just I am taking the what I am taking, just I am taking the one power system network. From that one, I am observing, I am getting the electrical power. Now I am trying to utilize that electrical power for the driving the DC loads. Okay, in that I am identify that I am requiring the some DC to DC converter. Okay, and later what I am done, instead of the single existing busbar network, okay, I am using the variable sources. That I may use the existing busbar network, or I may go with the alternative renewable energy sources. Okay, so and again to control the DC output, I am requiring the some controller here. So for that controller, I need to place the some controller either at the source side or at the load side. Okay, but here the problem is simple only, but the work is going elaborately. Okay, that means the whole work you don't need to work because of some work already done by the some other persons, but you need to select the any some small problem in this, and you need to try to get the solution for that only. Okay, so this is the fuel cell charging hydrogen fuel cell, and this is the simulation network to charge the electrical vehicle battery. Here I am getting the supply from the DC source, and here I am using the some DC to DC converter, and here I am using the some controller. Okay, to control the to get the desired output from the converter to charge the electrical vehicle battery. Okay, so that means I am getting the some idea in my mind. I need to use the some renewable energy sources. I need to use the DC to DC converter. I need to charge the electrical vehicle. So for that purpose, what I have done, I am taking the grid connected system here. At very first, I am taking the grid connected system. Later, I will replace this grid connected system with the fuel cell or the solar cell or the windmills. Okay, all those things. Okay, I may replace the source. And here I am using the DC to DC converter, and the output of the DC to DC converter, I am trying to get the charge on that one. Okay. So here I am requiring the some controller. Now I am connecting the controller at the load side instead of the source side. I may use the controller at the source side. Here in this case I am using the controller at the load side. So that means for what purpose I am explaining this thing, nothing but the how to explore our research work, how to find the problem to do that work. Okay, so if you observe some papers in the Google, all this work is available. But what you need to do here, they are using the simple buck and butter. Instead of the simple buck converter, you may take the some other simple converter, maybe boost or some KV converter, depends upon their voltages. The same work, if you replace the buck converter with the boost converter, your work is done, completed. Okay. Or otherwise, if they are using the some simple buck converter, they are using the PA controller here. Instead of the PA controller, if you use the fuzzy controller for the same thing, okay, if you identify the results PA controller with the fuzzy controller, some small modification you got in the results, okay, then your work is completed. Okay, that means what you need to do, you need to identify the simple problem, and you need to identify what are the existing methodologies are there on the same work, and you need to try to find the solution for that. That's all only you are doing. Okay, your required thing. Okay. So this is the variable sources, DC to DC converter. I'm charging the vehicle. So for what purpose I am using the DC to DC converter as a method? I already told that one, to get the variable input voltage into the fixed DC voltage. I am getting those things in. So for that purpose, okay, in the process, okay, this is the roadmap I am choosing to finish that work. I am choosing the some controller here, converter, DC to DC converter, and these are the different procedures I am trying to follow. One is first of all, I am trying to identify the working principle of that converter, then mathematical model, then power stage design, and then controller, and then the what are the for what purpose I am doing the work, what is the applications of the my work. In the working principle also, there are different types of the connections are there for the considered converter. I may use the any one of this one. In the modeling also, there are three different techniques are there. I may use the any one of that one. In the power stage, with the help of the required specifications, I am trying to calculate the power stage components. This controller also, there are various controllers are there. Analog controller, digital controller, other types of controller. In the analog also, voltage mode, current mode. In the current mode also, P current mode. Some other current mode, average current mode controller. In the digital also, there are various types are there. In the other controller, fuzzy logic controller, sliding controller. In the digital also, there is some other classifications there. So these are after doing the literature, you are able to find what are the existing work on that. If you want to do a work on that particular converter, okay. In this your project work, no need to do all those things. Okay, what you need to do, if they are designing the controller with simple voltage controller, instead of the voltage controller, if you are using the current mode controller, just you are changing the controller only for the same network. If you are getting some delta X better results from the voltage mode controller, your work is completed. Okay. Or otherwise, if you already voltage mode control is there, just instead of that one, you are using the fuzzy logic controller. If your fuzzy logic controller giving some delta X better results than the voltage mode controller, then also your work is completed. That means a small modification is required to finish your work. Okay. So that's why first of all you need to get some roadmap to complete that work. Okay. So in this today I am taking the simple example, one simple buck converter. Okay. So for the buck converter, what are the steps to be followed to complete the solution? Okay, I am explaining here. So instead of the buck converter, you may choose any one of the converter here. Okay, already fuel cell, solar cell, all those things, mathematical models and simulation blocks are available in your software. Okay, and you are having some load here. They may take the electrical vehicle load. You may take your mobile, or you may take some other electrical appliances you are using at your home. And in between, you are taking some DC to DC converter. It depends upon their required voltage. If you are using if you want to step down the voltage from high level to low level, you need to take the buck converter. If you want to step up the voltage, in that case, you need to take the boost converter. Okay, depends upon your application. You may choose what type of converter is required. Okay, so just for understanding purpose, I am taking the simple buck converter. Okay, at the very start, what we need to do, what we need to identify. First of all, what we need to identify here? We need to identify the working principle of our considered converter. Okay. So working principle nothing but here I am taking the buck converter. This is the gate control device. I am using the MOSFET here, gate control device. Here I am applying the DC supply. This is our load. And here there is also some inductor and capacitor is there. And diode and the gate control device. The sum is the MOSFET. Okay. If you give the turn on power supply to the Q1, what is the direction of current now? If you give the gate pulse to turn on the MOSFET, V1, from the V1 you are getting the some current I. Okay, if the Q1 is turned on, what about the diode D? Here positive polarity, negative polarity, Q1 is turned on. By giving the pulse signal, Q1 is turned on. What about the diode? This diode. కనపడతలేదా సర్క్యూట్ ఇమేంద్ర బాబు ఇక్కడ పాజిటివ్ సప్లై ఉంది డయోడ్ క్యాథోడ్ కి పాజిటివ్ సప్లై వచ్చింది కదా Q1 కండక్ట్ అయితే Q1 టర్న్ ఆన్ అయితే ఏమైంది కరెంట్ ఏమైంది ఇక్కడికి ఈ నోడ్ దగ్గర ఇటు కొంత డివైడ్ అయింది కదా ఇప్పుడు డయోడ్ ఏమైంది రివర్స్ బయాస్ అయింది డయోడ్ ఓపెన్ అయింది కరెంట్ ఎప్పుడు ఎటు ఫ్లో అయింది ఇండక్టర్ లో కన్నా ఫ్లో అయింది ఇండక్టర్ ఛార్జ్ అవుతా ఉంటుంది ఇది లీనియర్ గా ఇలా ఛార్జ్ అవుతా ఉంది ఓకేనా తర్వాత కాసేపు ఉన్నాక నెగటివ్ హాఫ్ సైకిల్ పల్స్ అనేది ఆఫ్ చేసాం అనుకోండి Q1 ఇఫ్ Q1 is turned off Q1 is acts as open circuit this capacitor inductor is on the already charged condition okay inductor does not allow the sudden changes in the current that's why always the current is need to flow in this direction only okay then what about the diode Diode will in forward bias condition, the current direction is like this. Now the inductor gets discharged. Okay, that means one is the turn on condition, other one is the turn off condition. So D times of the T, we are getting the turn on. So if it is turned on, voltage in the turn on condition is the D times of the T into Vn minus V. The voltage across the inductor is Vn minus V and during the off condition 1 minus the TL, the output voltage is V only. Finally we are getting the output voltage V equal to D times of the Vn where D is the duty cycle, it is always in between the 0 to 1. That's why you are getting the, from the circuit you are getting the step down voltage, that's why we are called it as a buck converter. Okay, so this is the first step. In the first step what we need to do? We need to identify the working principle of our circuit. Okay. In the similar manner, you may observe the working principle of the boost converter. Okay. Boost converter means it is stepping up the voltage. Okay. For the step up purpose, we are using the boost converter. Okay. So in our research, someone already worked on the buck converter. Okay. I need to replace the some buck converter with some other name. Okay, so in that case, what they have done? They call it as the K-way converter. K-way converter also, if you write the expression, you are getting the same buck converter expression only. Okay, but in the buck converter, what they have done? They are using the only one MOSFET, one diode, one inductor, and one capacitor only. But in the K-way converter, depends upon the required voltage, required stepping down. They are instead of one, they are using the two MOSFETs and one capacitor is extra they are using. Okay, they simply name it as a K-way converter. Okay, just if you are comparing the results of the buck converter and K-way converter, in that case also your work is completed for the same network. If already they are using the buck converter, if you replace the buck converter with the K-way converter, then also your work is completed. Okay, like that you need to identify the what are the different types of the methodologies existing in the existed for your work and then you need to try to find the solution for that. Okay, these are the some other applications. So first step is completed. In the first step we are identifying the working principle. In the second step what we have done, we are using the mathematical model. Okay, second step what we are doing, we are using the mathematical model for that. Okay, to find the mathematical model nothing but the In the control system subject, you are already studied. When at the very start, what you are using? Simple Laplace transform technique to find the relation between the input and output. Then you are going for the Blocker reduction technique. After that, you are going for the signal flow graph. Okay, those three are used only for the single input and single output. But for multi-input and multi-output system, you are going for the state space analysis. Okay. So here also, one is the state space analysis, other one is the switching averaging technique, circuit averaging technique, small signal AC technique, like that. Various types of the mathematical modeling technique are there. Mathematical model nothing but the representation of the physical phenomena by its mathematical equivalent only. Okay, nothing is different. So in the state space analysis, what we are done again, we are taking the same buck converter. In the working principle, we identify that during the turn-on condition of the MOSFET, our equivalent circuit is like this. They are writing the state equation. The state equation nothing but the one is the inductor voltage and the capacitive current. They are writing the expression for that, and that expression they are representing in the matrix form. Okay. So here, what is the voltage across the inductor? Voltage across the inductor VL equal to what? Vn minus V. VL means what? L into di by dt. Here I dot nothing but the di by dt. That L comes under the denominator. Di by dt equal to minus 1 times of the output voltage by L plus 1 times of the input voltage by L. Okay, Vn minus V kada. Same other formula, mathematical formula ni matrix formula represent చేశారు అంతే. ఓకేనా? ఇది ఫస్ట్ వన్. సెకండ్ వన్ ఏం చేశారు? During the turn off condition of the main MOSFET, you are getting the equivalent circuit like this. Okay. So for the equivalent circuit, again they are writing the same equation, state equation, and they are representing in the matrix form. Okay. So on state space average nothing but they are taking the average of those two with A matrix equal to D times of the A on matrix and 1 minus D times of the A of matrix, and final B matrix equal to D times of the B on and 1 minus D times of the B of, where A on means what? The matrix A during the turn on condition of the main MOSFET. B on means what? Matrix B during the turn on condition of the main MOSFET. Okay. And second one is the A of nothing but what? A matrix belongs to the turn off condition of the main matrix. B of means what? B matrix corresponding to the turn off condition of the main MOSFET. Okay. So these two cases we are already explained in the working principle. The same thing, by taking the average of those things, finally we are getting the A matrix and B matrix. And to get the small signal variation, we are taking this is the DC component, and a small signal variation. For what purpose we are done? In your power system applications, most of the applications, for every second to second, what happens? There is some change in the load. There is some change in the supply terminals, supply voltage. That's why that small signal variation we are consider. So instead of X, they are replacing the capital X with the X cap, where X is the DC voltage, X exact voltage, and X cap is the variation in the X. Similarly, U is the input, U is the fixed U, and U cap is the variable U. Okay, this U cap and X cap, D cap are very far less than the actual values. By considering that variation, finally we are calculating the mathematical model of the A matrix, B matrix, all those things. Okay, and finally what we need to do? We need to take the relation between the input and output. To that, once we are getting the A matrix, B matrix, C matrix, what is the expression for the transfer function? C into Si minus A inverse B, okay, plus E. Okay, that by using that formula, we are able to calculate the final relation between the input and output, even by using the state space analysis instead of the Laplace transform technique or Blocker reduction technique or the signal flow graph. Okay, the same process he may done with the boost converter during the turn on of main MOSFET and run off of the main MOSFET. So whatever may be the converter, you can use the same process. You are able to identify the relation between the input and output. For a KY converter also the same process. A matrix, B matrix, C matrix. So from that one, C into Si minus A inverse B, you are giving the final mathematical model. So in the MATLAB, once you are having the state space, there is a directly you are able to represent the A matrix, B matrix, C matrix in this by using this block, or if you are able to transfer the transfer function C into Si minus A inverse B plus D. Okay. So it is giving the relation between the input and output. Okay. Now how many steps are completed? Hello. ఏం చేస్తున్నారు ఎన్ని స్టెప్స్ అయిపోయినాయి? ఫస్ట్ ఏం చేసాము? At very start we are discussing about the working principle. In the second step what we have done? We are identifying the mathematical model. Mathematical model means what? Representation of the physical phenomena by its mathematical meaning. Kana physical circuit ni mathematical lo convert చేసాము. ఇక్కడ మనకు ట్రాన్స్ఫర్ ఫంక్షన్ వచ్చింది. ఓకేనా? ఈ ట్రాన్స్ఫర్ ఫంక్షన్ మనం ఏం చేయాలి? ఏదో ఒక సాఫ్ట్వేర్ లో బిల్డ్ చేయాలి. బిల్డ్ చేయాలంటే మన దగ్గర ఉన్న సిస్టానికి కొన్ని పారామీటర్స్ ఉంటాయి కదా. ఓకేనా? ఇక్కడ మనం తీసుకున్న సర్క్యూట్ లో కూడా ఎంత ఇన్పుట్ వోల్టేజ్ ఇవ్వాలి, ఎంత అవుట్పుట్ రావాలి, మధ్యలో ఇండక్టర్ వాల్యూ, కెపాసిటర్ వాల్యూ, వీటన్నిటికి ఏమి ఇవ్వాలి? మనం పారామీటర్స్ ఇవ్వాలి. ఓకేనా? సో అందుకోసం మనం ఏం చేయాలంటే మనం ఇనీషియల్ గా ప్రాబ్లం డిఫైన్ చేసేటప్పుడే ఇన్పుట్ వోల్టేజ్ అసలు ఎంత వస్తుంది, మనకి ఎంత అవుట్పుట్, మన లోడ్ డ్రైవ్ చేయడానికి how much output voltage we need to get, that thing we need to identify at a very start. Okay. So while defining the problem itself, we need to identify that from these sources how much amount of the voltage we are getting and how much amount of the voltage at what current we need to get the power supply to drive our load. That means at the problem identification itself, we need to identify the input parameters and output parameters. Okay. Once you know the input parameters and output parameters, after completion of the work, finding the working principle and mathematical model for your considered circuit, what you need to do? You need to find the values of the inductor value and capacitor value. That is called as the calculation of the parameters. So this is the input. I am considering the 28 volts input. I am requiring the 15 volts DC. My MOSFET is running at the 100 kilohertz and final output power to drive the load is the 75. Okay. From the voltage balance condition for that circuit, this is the formula to calculate the inductor value and the capacitor value by substituting the input voltage and output voltage and load resistance value, MOSFET switching frequency. So, and based upon the input voltage and output voltage, we are able to calculate the D value also. From that, by substituting those values, we need to calculate the parameters of the circuit. Those are the L0 value and the C0 value. Okay. In the similarly, for the boost converter also, by considering the some other, here they are considering the 12 volts input and 24 volts output. Switching frequency here they are considering only 40 kilohertz only. And output power they are requiring to drive their load 57.6 watts. Based upon that one, they are calculate the inductor value and the capacitor value. Okay. So for the KY converter, they are taking the input voltage in 12 to 18. They are considering the approximate 16 volts. Output they are required 24 volts. Switching frequency 100 kilohertz. Output power they are requiring the 100 watts. Based upon that one, by using these formulas, they are calculate the system parameters. Okay. So that means for all the converter, that's not the same problem, same formula. Okay. Each and every converter having the its own formula to calculate that system parameters. Okay. These are already published in the some other papers. Okay. You can take the help of that papers or some standard textbooks are there. From that also you can take, and you need to calculate the system parameter based upon your system for your required values. Okay. So after that this is the third step completed. Okay. Now we are having the system transfer function. We are having the system parameters. Just you need to simulate those things. This is the simple input voltage, simple buck converter. We are taking the output voltage V is the 15 volts. We are requiring these things. And a simple voltage converter I am using. And to give the pulse signal to that one, we are using the pulse width modulation technique. By using that one, I am generating the some pulse signal and I am giving the same thing to the MOSFET to drive the MOSFET. Okay. So these are the our input voltages, required output voltage calculated, inductor and capacitor and load resistor value, switching frequency. So for that, okay, if you simulate this thing, this is the simulation circuit. From that one, you can observe the some results. Okay, so this is the frequency response board plot, something you are already done in the control system subject. This is the frequency response and this is the time response. Okay, so from the time response, what we are expecting? We are expecting the output voltage is how much? 15 volts. Okay, we are expecting output voltage how much? 15 volts, but it is able to give the only around 11 kilovolts only. Okay. So, but what we need to do? We need to change the system parameters. We need to change the some controller parameters here. By changing this controller parameters, what we need to do? Finally, we need to use the. We need to get the here required voltage 15 volts at the required voltage output power or the current. Okay. So this thing, this analysis you may do in the time domain analysis or the frequency domain analysis. If you are using the time domain analysis, by considering this graph only, you can observe, or by using the frequency domain analysis with the help of this one, by observing the gain margin and phase margin from the board plot without controller, you can design a controller and then for the required phase margin and gain margin, you may design a controller and that value, controller values you need to place here. And finally, you need to observe the output response. By using the frequency analysis or whatever may be the analysis, finally you need to get the desired output from this one. Okay, so this is the process. We need to design a controller to get the desired output from response from that one. Okay, now my doubt is that one, how we are getting the variable output voltage from the DC to DC converter. What are the main reasons? Most of the cases, our source is varying from time to time. By changing the load also, we are getting the variable output voltage. And we are at the time of the parameters calculation, at present we are designing the, for example, if you are calculating inductor is 5 microhenry, capacitor is 100 microfarads. Today we are calculating, but after some years, if you are using the same circuit, due to the aging effect also, that values may be vary. That's why you may get the variation in the output voltage, even though you are calculated the parameters based upon their required parameters, but you may get the variable voltage due to that one. Okay, that means one is the due to the input parameter variation or due to the load variation or the input variation, load variation or the parameter variation. Due to all these things, we are getting the variable output voltage. Okay. So the similar process you may use for the boost converter. This is the boost converter circuit. And here they are designing the controller. Okay, to observe the whether your design control is working properly or not, to identify that one, they are giving the some disturbance at the source side and load side. Even though by applying the disturbances you are getting the constant voltage, then they confirm that your design control is working properly. Okay, so like that you need to give the some disturbances, artificial disturbance at the source side and load side. You need to check the validity of the your converter. Okay, so like that you may done the simulation for the various types of the controller. Okay, this is the frequency response analysis method. If you are taking the frequency response method to design a controller, okay, these are the formulas you may use. Okay, so like that, finally you need to get the solution for that. Okay, that today's intention is that. So this is the after finally 15 volts we are required. We are getting the 15 volts output. Okay, after designing the proper controller, even though they are giving the disturbance at the 0.03 and 0.06, we are getting the desired outputs from the response. Okay, so this is about the PI controller. The same thing, fuzzy logic controller is very similar, nearer to that of the PA controller. In the PA controller also only two parameters are, one is the proportional, another one is the integral. So here also there are, one is the error, other one is the change in error. Okay, so the PA controller is very near to that of the PI controller. Once you are having the idea about the PI controller, for simple modification, you may use the fuzzy logic controller also. So here we need to take the some membership function here, fuzzy logic controller. But these are the memberships, input membership and output memberships. Input memberships, there are two types, one is for the error, another one is for the changing error, and this is the output memberships. And finally, with the help of this flowchart, you may design a fuzzy logic controller, and this is the simulation circuit for the by using the fuzzy logic. And in the subsystem, we are using the renewable energy sources, and this is the DC to DC converter. This is our electric vehicle load, and here I am designing the fuzzy logic controller. Okay, so and then with the fuzzy logic controller, I am getting this is the input voltage 800 volts. I am requiring the some 400 volts output here. The same 400 volts without any difference. I am getting the better results than the PI controller in case of the fuzzy logic controller. Okay. So like that, with a simple modification for the existing work, we are able to identify the solution for that. Okay. From this session, what we need to identify for doing a research, what we need to have, first of all, we need to do a complete literature. In the literature, what we need to identify, there is just some existing work. From that existing work, we need to research the work. Okay. For the existing work, what you need to do, whatever the problem, for that recording that problem, what earlier people have done, some work on that one, what they have done, what type of methodologies they are using. So that thing we need to identify the problem. So after identifying the problem, what we need to do, we need to, after defining the problem, we need to have the some roadmap to find the solution for your problem. Okay. If you have done the work on the, if I am done the work on the DC to DC converters, I am having the roadmap that initially what I need to do, I need to identify the working principle of the for the considered converter. And the second step, what I need to do, I need to use the any one of the mathematical modeling technique. By using that mathematical modeling technique, I need to represent the physical phenomena with the mathematical model. Okay, representation of the physical phenomena in the mathematical equivalent. Once the mathematical equivalent is available, what I need to do in the third step, what I need to do, I need to calculate the system parameters by considering the input and output. Okay, input, how I need to consider, what are the types of sources I am using. From that sort, how much amount of input energy I am getting, that thing I need to observe. And I am designing the circuit for a particular application. Based upon that application, I need to identify that what are the output voltage and at what current I require the to drive that load, how much power I require, that thing I need to observe. So based upon that one, I need to calculate the system parameter by considering the MOSFETs and other parameters. Okay, by considering the switching frequency. Okay, after designing the parameter, what I am done, I am simulated the consider circuit by using any one of the software. First of all, I am observing the output response without any controller. Okay. Without controller, what I am doing? I am expecting the 15 volts output voltage, but I am unable to get the 15 volts output. Okay. The reason may be the input voltage variation, or maybe the load variation, or maybe the system parameter variation. Okay. So with all these reasons, I need to identify I need to place some controller. That controller may be the voltage mode controller or current mode controller, or some other types of the controllers are available. I need to choose any one of that one. Okay, while choosing that one, I need to observe that what are the real people have done and what type of the controller they are using and what they are getting. Okay, for my applications, what I need to change some delta X from the previous work. Okay, by using that I need to choose any one of the controller. So by using that controller, some methodology is already available. Okay, whatever the controller we are using, that methodology already available in the existing work. Okay, but for my application, what I need to do, I need to use the same methodology, but I need to get some better results on the same system than the previous work. Okay, that's why I am designing the controller, I am comparing the output results with the previous one, and finally, to check the validity of my work, what I have done, I am giving the artificial input at the source side and artificial input at the load side. Okay, even though disturbances creating at the source side and load side, if I am getting the desired output voltage, then I am able to confirm that my work is valid. Okay, so with this one, once I am getting the confirmed results, okay, my task is completed. So later, after completion of my work, what I need to do? I need to publish a paper. Okay, once paper is published, if I am I may live alive in the earth or I may not live on the earth, but my paper is on active. Okay, once you type the name, okay, your work, once after publication of making the publication of your work, once you type your name on the Google, okay, after 2000 years or 1000 years, okay, your paper will get. Okay, you may live on the earth, you may not live on the earth, but your research work is available for all other people. Okay, that's why for your credit, you need to make the publication. That publication may be towards the conference or towards the journal or towards the patent. Okay, so in view of that one, for helping your project work, we people are trying to give the some spark on that one. Okay, generally we know that one, a spark will make the fire to fire a lot. ఓకేనా, ఒక అడవి మొత్తాన్ని తగలబెట్టాలని ఏం కావాలి, చిన్న స్పార్క్ సరిపోయింది. ఆ స్పార్క్ కనుక వస్తే ఆ స్పార్క్ వల్ల వచ్చే ఫైరు, ఓకేనా, సో అడవి మొత్తాన్ని తగలబెట్టింది కాబట్టి, సో వీఆర్ ట్రైంగ్ టు మేక్ దట్ స్పార్క్, ఓకే, టు మేక్ ద ఫైర్, సో దట్ ఫైర్ విల్ ఫైర్. ఓకే, so with that yesterday we are discussing about the latex software to make the, okay, na, a project report, all those things. So that the templates department already will give to you. Okay, and the second session, Sir will explain about the how to do the research. Okay, in the continuation of that one, by taking the simple problem, how to find the solution, how to make the roadmap. Today I am explaining. So Sampal Sir is explained about the how to make the patent publication. Okay, in the latest software, some easy version is there. Okay, regarding that same thing will continue by the Dr.J.Ravindra garu tomorrow morning. Okay, and on the second session, along with the patent publication, some persons need to publish your work via conferences or the journal. So Dr. K. Ramesh garu will explain about the how to make the international conference paper and how to make the publication in the journal. Okay, all those things will explain by the Dr. K. Ramesh garu. And latex software, regarding the latex software, Dr. J. Ravindra garu will explain that tomorrow morning. Okay, so all the 6 sections will planned only in view of your project only. Okay, so that's why please use that one. Okay, I thank you very much giving me an opportunity, okay, for listening my session. So thank you one and all.